Hi everybody. In this video I'll be talking about the travel cost method, and this is one of a series of different environmental valuation methods that we can use to put a monetary price on some type of natural asset or ecosystem service or some environmental attribute. So let's look at how this particular method works. So as I've explained in previous videos, we can categorize the different benefits that we receive, these different values, and commonly economists classify them or categorize them into these direct use benefits or values, indirect use, and non-use values. And I've covered this in previous videos, but just again, we have these natural assets or ecosystems, and they are providing benefits to us, either, by us enjoying iconic sites like Uluru or the Glasshouse Mountains, or through, for instance, the ecosystem services that they provide to us and their economic contribution to that. So we are the beneficiaries, so it's a human-centric view. We get these different values. And the values then are direct use values. For example, we can go fishing and catch a fish and eat it, so we are directly consuming part of the environment there. They can be non-consumptive direct uses. So for example, when we go out and go surfing or go swimming in a local stream, or we're bird watching or enjoying a sunset. So these are non-consumptive uses. And that will be what we focus on in this particular video, which is the travel cost method is a way of determining these. But there's also these indirect use values here, and those are ecosystem services. So for example, pollination or carbon sequestration, pollination, which provides the food for us through bees pollinating flowers, which are producing fruit and so on. Carbon sequestration, which maintains the climate, provides us a livable climate and so on. So we get these indirect use values. And then finally, we have these non-use values, which are values that we place on the existence of the environment as a whole, and our stewardship of it for future generations and so on. So these, bequest and existence, stewardship types of values would be non-use values. But in this video, we'll again be focusing on direct use and using the travel cost method then to determine how much people are valuing in dollar terms some activity, for example, going and surfing or swimming at a beach. So the travel cost method then is one of a series of different environmental valuation methods, and it falls within the revealed preference method category. So it focuses on direct use values rather than indirect or non-use. And the method itself involves collecting data on the costs that people incur to travel to a recreational site or amenity. So for example, here in the image, I have, how much are people paying to travel to Malulupa Beach to go surfing there, or to, be swimming up here. And so the price that people are paying then in this instance is the cost that they're actually incurring to travel there, in terms of their fuel, in terms of their accommodation, in terms of the equipment that they need. All of those, if there's an entrance fee for access to this area, all of those make up their travel costs to consume that environmental asset. So we can create a demand curve then with this method, and normally where we would have a price quantity combination on a demand curve, as you're familiar with, here the price is the actual travel cost that these visitors are incurring, and the quantity consumed is the number of visits that they're making, and that's typically in a season or in a year. So we know from our previous videos on microtheory and demand and utility and marginal willingness to pay and so on, if people are actually going to the site and spending that that money to travel there, then we know that the travel cost then for them at least represents a lower boundary of their maximum willingness to pay. And indeed, we know that for most people, they would be willing to pay more than that if they had to. So it's important then that we recognize that and understand that, and we can use it to determine the consumer surplus, which is how much additional benefit are people getting from not having to pay their full willingness to pay. So let's go into that in a bit more. Okay, so just a recap then on consumer surplus. So here's a typical downward sloping demand curve where we have a price quantity combination. And so let's imagine we have a price here of around 17, and this was, for instance, an individual. So we can say that how much would this individual be willing to pay for the first unit of this particular good? Well, we can look at the demand curve. We can come across here to the quantity, the first quantity, and come up here and say, okay, well, it's somewhere around $35 that they would be willing to pay for that first unit. And similarly for the second unit, something slightly less, maybe around 30, and this follows from the logic of diminishing marginal utility, that people tend to get less out of increasing consumption of the same thing over time, or as they go along here. So this is their willingness to pay then, this demand curve, marginal willingness to pay. But in fact, what they're paying here is less. So they're only really paying $17. So they're getting this additional benefit for that first one. They would have paid, well, what is it, almost 33. They only have to pay 17. So this difference here then is called consumer surplus. And we can look at that across all of their consumption, presumably right up to this point here, 10 units, and add up all of that consumer surplus then to determine, in the case of the travel cost method, then that is what we're using to estimate the total value of that, the trips to the site and so on. And just again to restate what we've covered in previous videos, then similarly for producers, and we won't go into it in this method, producers have a surplus and their supply curve represents their marginal cost curve. And so they could provide the first unit here, at about $5, but in fact they're getting 17, so they're getting a producer surplus because the price in the market is higher than what they could conceivably supply into the market, and all the way up to here. So there's that producer surplus and the consumer surplus. Okay, so let's look in more detail then about this travel cost method. And I think it's probably best to start with the final step in the method, so you can see that, and then work backwards into the preceding steps. So here's the final step. Imagine that we have determined this generalized demand function, this generalized demand curve for some representative individual that is going down and recreating. Let's call it Mooloolaba Beach. So here we have this representative person, has a demand curve. It has this shape to it. In this case, it's linear, which means it's a straight line rather than some type of curve. And from this, we can also see that the average number of trips that they make in a season is 5, and that the average travel cost that they make there is $30. So it costs them $30 to travel, from Brisbane up to the Sunshine Coast to go surfing at Mooloolaba Beach each time in terms of fuel and so on. So that's their average travel cost and their average trip. So we can, look at that full 5 trips then and say, well, they pay $30 for each of those 5 trips. In total, then their travel cost is $150. But we can also see from their marginal willingness to pay then that they get this consumer surplus, right? So that there would have been some higher value had there been a travel cost of around $80. Nobody would have visited the site, and as it becomes less expensive, then more people visit. So this area underneath here is what we're interested in calculating, the consumer surplus. So if the person then makes 5 trips annually and the cost of each trip is $30, as we can see there, for the cost of fuel and parking and equipment and supplies and so on, then we can add that up. That would be, the total travel cost there. And we know that if the cost of travel was greater than $80, they wouldn't make any visits. So this person's willingness to pay then for the 5 visits, we can calculate this consumer surplus here. Their willingness to pay is in fact this amount here, both the travel cost, what they actually pay, and the consumer surplus, which is what they would have been willing to pay. For instance, if they were in an auction and had to purchase them one by one at the maximum amount they would be willing to pay. So that combination there of consumer surplus and travel cost there is the total willingness to pay. And we can figure out the consumer surplus then by calculating the area of this triangle. And in the case of this linear example, it's quite straightforward. We can say that the consumer surplus is half, That's the area of a triangle. So it's half of, a square like this. So that is half of, first of all, the difference here. So this is 80 minus 30. So that is this 50 here. So, that is 50. They are consuming 5 trips. So 50 times 5 there. And then, so 250, but we would divide that by half because it's a triangle. It's only this part here. So that consumer surplus then in this particular example is 125. But note that that is the consumer surplus for all 5 of those trips, right? That's the total consumer surplus. So we're interested in, well, what is the average consumer surplus per trip? Now we can just divide that by 5 because they made 5 trips. So 125 divided by 5 is equal to 25. So on average, this representative individual is getting $25 of consumer surplus. That is what we're saying, this additional value of the site. And so we can use that figure then if we were to say then if this person is representative of all of the people visiting this particular beach. Let's imagine that there were 1 million similar visitors to this site annually. Well, now we could say, well, 1 million similar visitors, each of which is obtaining this consumer surplus of $25 per trip. Gives us a total of $25 million. So that $25 times 1 million, 25 million. So based on the travel cost method, then we could conclude that the direct use value of the recreational site is $25 million per year. So that's that final stage of the whole process. But we're interested in how do we get there. So let's go back now through the different steps of it. So in more general terms then, we have some functional relationship here. So where we have XN, I'm going to call it, is the trips per season. And that would be a function of several different things, like how many trips per season would a person make to this particular site or to any sites? Well, that would be a function of a number of different variables. And those variables would be, for instance, well, what is the actual travel cost to get to that site? So I'm calling that TC, travel cost, and then brackets M for main. So that is really saying that is the primary purpose of their trip, or the main purpose of their trip is to go to that particular site. N represents the individual, and this would be, N, we would have a large population, so there would be many different people. So we would undertake this analysis for each person. So we would look at what the travel cost is for that person. There would also be a travel cost to substitute sites. So we have to think in terms of, demand for people. If there are alternatives that they could go to, they would also be considering those. So TC brackets S here would be a vector, which would mean, a list of travel costs to substitute sites. So that, for example, might be going to the Australia Zoo instead, or going to Noosa instead. So we would have a whole, whereas this is just the travel cost for the main site, this would be a list or a vector of different travel costs for substitute sites. And we know that, the price of substitutes would affect demand for the primary good. It would also have a vector of different demographic characteristics that would influence demand. So, for example, the size of the family, or their interest in that particular recreational activity, or some other set of characteristics, whether or not they were part of a surf life-saving association. A bunch of different demographic characteristics then would influence a person's demand for a number of trips per year to this site. And finally, we would have an income variable. So we know from our earlier demand theory that income is one of the different factors that would shift the demand curve out. So these ones here are different variables that would shift the demand curve, and the travel cost to the main site itself is essentially the price of it. So that would be, that would cause a movement along the curve. Okay, so then the step then would be to survey a large number of people and to use that data that we obtained. So we would collect information on all of those different variables for a large number of people. and then we would do a regression analysis, as I'll mention in a minute, and we would determine what is the average or median values, to create a representative individual, and then we would create this representative demand function, which is what we're looking for in that last step. All right. So we have trips per season, total cost per trip. This is the total cost. This is called the choke price, actually, which is the cost at which nobody would travel to the site. Here is the travel cost, which would be perhaps to the main site, and this would be either an average or a median. We would have the average trips per year, and then we would have this, as we talked about before here, the total willingness to pay would be the combination of A and B being the travel costs, A being the consumer surplus. And that A, consumer surplus, is what we're trying to determine. And it's actually also referred to as the access value. So we're going to aggregate that up once we know it for the population of visitors, and that will be how we come to our total value for that site. So let's now go back to the beginning and see how we would do this in practice. It's worth mentioning, especially if you're reading different journal papers and so on, or textbooks, that there's two common approaches here: an individual travel cost method and a zonal method. So the individual travel cost method is where we would collect information on individuals, a large number of them, and typically that would be through surveys, both on-site and off-site surveys. So that's a combination of being down with your survey at, for instance, Mooloolaba Beach, as well as off-site surveys, which might be by phone or by email and so on. And so we would collect a large amount of information from a bunch of different respondents there about their travel patterns, how far they went, how much money they made, how many people they went with, where they stayed, how much it cost to stay, all of that information. And we would then use regression analysis to find this relationship, which is between travel cost and the quantity consumed. So there's a second, simpler method, and that's called the zonal method. And the zonal method breaks up the area around the site of interest into different zones. For example, if we were thinking about, Kakadu Park or Uluru or, Mooloolaba Beach, we would establish a set of zones around that. And this, might be concentric circles moving out further and further from that zone. We could use postal codes or cities or some other kinds of measures to establish these different zones. And the purpose here would be kind of simplifying the method so that we would assume that everybody within a particular zone would have the same travel costs. We might then be able to, because they're traveling presumably a similar distance from that zone, so that would help to simplify the data collection, and we might be able to even use existing demographic data, for instance, ABS data, Australian Bureau of Statistics data, on demographic characteristics of people that lived in that subdivision, in that postal code, and then we could supplement it perhaps with some limited on-site or off-site surveys to elaborate that survey. So in general, though, the zonal method is simpler and less expensive, but it's considered less accurate. And so what I'll be describing in the remainder of this presentation is instead the individual travel cost method. So once again, we want to get ultimately to some kind of something that looks like this, where we have this representative demand function that we can work from. Okay, so what are the steps in getting there? Well, first of all, we need to define the site that we're actually interested in valuing. So let's take an example here and imagine we're interested in conducting a travel cost survey using the travel cost method to determine, well, what is the value of surfing and swimming and recreating in the beaches that go from the headlands here at Mooloolaba all the way up to Cotton Tree. So we define this area here, okay, and we exclude everything outside of that. Then we look at what are the recreational activities that we're interested in here. So for example, maybe it's surfing and water recreation as opposed to, for instance, fishing or something else like that. So we define those recreational characteristics. And then we need to come up with a sampling strategy, which is to say, how much on-site and off-site surveying will we actually do, and will it be in person or by phone or by email? What extent of the wider population will we survey? And so this is consequential to the results we're going to get. For example, if we only do on-site surveys here of people, then we'll find, well, we're going to have a sample selection bias. We will, in fact, only be getting responses from people that are there on that particular day. So we'll know that they're using it, and we could at least get some good information about how far they've traveled and all the costs and so on. But we may not pick up the people that, traveled there last week and that have gone back to Brisbane or have gone, back to Darwin or whatever it is. So there's a rationale then for both on-site and off-site surveys. Now, when we survey people off-site then, we have different issues in that, we might survey a bunch of people from Brisbane who don't go there, who don't have, any travel costs associated with it. But anyway, so commonly we use a combination of on-site and off-site surveys to get a larger representative sample of the, of the people that would be traveling to that site in a particular year. So the next thing we need to do is specify the model, which is to say the functional form of the equations and even the regression methods that we'll employ and so on. So if I go back to that equation that I had early on here, that would be a representative functional form of this. And we would be then interested in figuring out, what are really which of the different influences on demand are we going to try to collect information on and estimate. So, the travel cost to substitute sites, which kinds of demographic characteristics. So, will we collect information on family size, level of education and age, and, whether or not people have experience in the activity that they're going to undertake. All of these potentially could shift their demand for trips or visits to that site in a particular year. And of course, we collect income and so on. So we define that functional form. The next thing we'll want to do is design a survey instrument that will help us to actually collect the data that we need to do that analysis. So, how far did you travel today? How many people are you staying with? What is your occupation? What is your average wage rate? All of those kinds of things we would collect in some type of a survey instrument. Then we would need to, undertake this regression analysis. So we would set up some kind of functional equation here. So this is an example that I took from a paper. And so here they have, this particular variable here is the visits per year. So we're interested, our dependent variable in this case is actually the number of visits per year. So how many times do they go to Malulaba Beach? And then we'll have some kind of an equation here that we're trying to estimate, where we would have one of the different variables we're interested in, the independent variables, is the travel cost of that location. This looks like on-site costs. Here's income. There would be other types of things. In this case, are they a visitor or a local resident? So we would set up our functional form and, collect some different information on that. And ultimately, what we're trying to do is some regression analysis here, where we're trying to figure out what is the sign and magnitude of this travel cost variable. And we would expect that when we collect a bunch of information from different people, and those are, different people in our sample survey, we would find that people that are further away from the site would have a higher travel cost to get there. So presumably, people here that are further away from the site would have higher costs and would presumably then travel less, would make less visits there per year. So when we see the whole population here, we get this benefit of because we've sampled a large area, and now we can see that people that are traveling a long distance have a higher travel cost to get there. They are consuming, less trips per year. People that are closer have lower travel costs. They're consuming more trips per year. That actually allows us to estimate this relationship here between travel cost and visits, from which we can derive a demand curve. So that's really what we're looking for here. And so here's the example from that study. So they did this regression analysis, and I won't go into the different kinds of methods that can be used there, ordinary least squares and so on. There are, preferred methods for doing that. And they found, so this is really the coefficient of interest here, which is the travel cost influence on the visits per year, and theirs is negative, negative 0.07. So that negative relationship there is really saying, well, the higher the travel costs, then the fewer the visits, and that's exactly what we would expect here: higher travel costs, fewer visits, and we can use that coefficient then, as a slope estimate of the demand curve, and we can then construct essentially this demand curve for our representative population. So these numbers will be, average or median values across we will use average or median values across the entire population of visitors. So ultimately what we'll get here then is, people who had to travel further have higher costs, make fewer trips. People that are closer have lower travel costs, make more trips. We then have enough information to estimate this demand curve. And then what we can do is also figure out, well, what is the average cost, or perhaps the median travel cost for a representative individual that's visiting the site, and how many trips are they making per season? What is the average or median value of the trips? So that allows us then to calculate these travel costs, but more importantly, it allows us to calculate this consumer surplus. So that's really, now I'm back to that very end step that I described earlier on in the video. That's what we're after there, is coming up with a per trip consumer surplus. And once we have that, then we're able to apply that to, then we're able to, apply that number, that consumer surplus, to the wider number of visitors that are recreating at that beach. So for example, if we come up with something that says the average consumer surplus for going to Malulaba Beach was, $17, then, and we know that 500,000 people go to that beach each year, then we can multiply the 17 by the 500,000 and come up with a total value for recreation at Malulaba Beach. It can also be used, and this is quite important then, to think about, well, what would happen if we changed some quality feature of that, beach experience? So for example, if we did something upstream to improve the water quality that was the fresh water that empties out into the ocean nearby, and for people that were swimming and surfing there, then the beach water was that much cleaner. Or what if we provided additional amenities, like maybe more park benches, or maybe more barbecues, or if we increased parking? So we can look at, what if we were to make some investment to improve the characteristics of that overall experience? Well, we know that when we improve the quality of something, that for the same price, people will demand more for it. The market will demand more for it. Or alternatively, we could say, for the same number in terms of consumption, then people would pay a higher price for it. So we know that those quality features then would cause a shift in the demand curve. So that's what I'm illustrating here. So we make this investment, we improve the quality, we increase amenities and access and so on. The demand curve shifts outward. Well, now what we can do is undertake this analysis again and figure out, what is this additional consumer surplus here that is being obtained by all of the visitors? And so we would aggregate that up, and then we could compare that to the cost of the investment. So we may find that, a $1 million investment in improving the amenities down at Malulaba Beach increased visitation, and the overall, increase in the total value, the consumer surplus, was maybe $2 million per year, or $20 million over 10 years or something. So we would be able to undertake this cost-benefit analysis. Is that a good investment to make? So there are some issues with the travel cost method that I should point out. For example, one of them would be, well, what is, if we're going to have a total cost of the experience, presumably part of that would be, how much are people giving up in foregone wages to go to that site? So we would be interested in, what is their wage rate? But then the question becomes, well, how much should we actually include in that? For example, their full salary, or how would we work with retired people who might live close and so on. So studies typically use around 40% of the wage rate. Reverse studies have been done to try to estimate what is the best value to put in there. It's somewhere around 40% of the wage rate. We would also be interested in, well, what other possible alternative recreation sites could that person have visited instead of the main one, because that may influence things. We would want to perhaps consider, and it's complex, well, what if the trip to Mooloolaba Beach was just one of a number of stops that people made, and we might overestimate the value of Mooloolaba Beach if they made a 2-day trip from Brisbane, but only half the time was spent at the beach and the other half of the time was spent in the Glasshouse Mountains. So we need to, and there is methods for taking account of these multi-purpose trips. So, and that gets down into travel motivations too, which is, did they just go to see one site, or did they go, did they just happen upon it along the way? What was the overall purpose of their trip? And also we need to think about, well, what about people that place such a high value on that environmental benefit that they live really close to it? So they would have presumably a low travel cost, but they may have, a really high value to it. And in fact, they relocated to be right next to the beach so they could enjoy it much more. So there are just some complexities in using this method that should be taken into consideration. So let's look at just a couple of examples of how the travel cost method has been used. And in the 2 examples I'm giving here would be coming up with a total value of the Great Barrier Reef. So here we've got one study here back in 2003 that used the travel cost method and found that the recreational value of the reef ranges from 700 million US per year to about 1.6 billion. And so that's estimated on, around 200 million visitors, and that the average person is deriving this benefit, this consumer surplus, of somewhere between $350 to $800 per visit. So one slightly more recent one here from 2016 from Deloitte Access Economics also looked at using the travel cost method to value the Great Barrier Reef and found that the per trip consumer surplus is about $662. So that is, again, the difference between what people would be willing to pay and what they actually have to pay in terms of travel cost. And that if you extrapolate that out to all of the visitors that go to the Great Barrier Reef, and they estimate that's around 2.3 million visitors per year, that would be a total economic value there of about $1.5 billion in annual direct benefits to domestic tourists. So that's just a brief explanation of the travel cost method and a few example applications of it. I hope you find that helpful. Thanks.